I'm Anil Kumar. Welcome to my series on transformations. Let us now discuss transformations when we're looking into functions of the type g of x equals to f of k of x. Now here x is being multiplied by k where k belongs to set of real numbers. Now in this case three things can happen. A combination of these three things can happen depending on the value of k. If k is less than 0, that means if k is negative, in that case the graph will be reflected on the y-axis. So you can say it is kind of reflected horizontally. Let me take an example to show you how it should look like. So let us say we take a square root function, which is actually a good example. So let's say this is the square root function. We'll consider 3 points on this. Let's say this is origin 0. And let's say this is a point which is 1 1, and then we'll consider a point which is let's say 4, and square root of 4 is 2. So we'll consider these 3 points on our function y equals to square root x. When it becomes a transformed function g of x, f k times x. So the x part is being multiplied, right? So if I have a function which is of the type square root of minus x, right? So that means k equals to negative 1. So k is less than 1, correct? In that case, the graph is reflected on the y-axis. That is to say, this is the y-axis. Each point will now be reflected on this axis. So the coordinates of the point will now be not 1, 1, but x value becomes negative. It will be negative 1, 1, correct? So we get a point here which is negative 1, 1. The other point which I am showing you as 4, 2 will now be reflected and will now become minus 4. The x value changes to negative, y value remains same, right? So we say horizontally reflected. So all the changes are only taking place on the x values, y remains same, right? So this graph will now be reflected and it will be looking like this, right? And of course the point right there, the origin, 0 gets multiplied by negative, it remains 0. So this is invariant point, so it doesn't change. So do you see that? So that is the effect when k value is negative, correct? Now let's take the value of k, which is, let me talk about absolute value of k now. It could be negative or positive, but absolute value is greater than 1. That means it could be like minus 2, something like this, or even 2, 3, 4. If it is greater than 1, in that case, the graph will be horizontally compressed. By a factor of 1 over k, right? So compressed. So if k is 2, it becomes half horizontally. So let me take another example for that. Let's say we take y equals to, so greater than 1 means, let's say square root of 2x. So 2 is greater than 1. Now in that case, horizontally compressed by a factor of 1 over k really means that the x values will now become half of original values. So this value at 1, 1 will now be shown at half 1. So x value becomes half. Do you see that? And the point 4, 2 will now be at 2, 2. So those are the new values for us. And the 0 remains at 0, right? 0 times half is 0. So we get a graph which is kind of like this. Do you see that? So the graph has moved towards the y-axis, closer, right? So compressed horizontally. Do you see that? Compressed horizontally. So it's become less wide. That is what we mean when we say the absolute value of k is greater than 1. So is that clear, right? So that becomes the graph for 2k. That becomes the graph of 2x. Okay? So that is how it should look like. Now let's take an example where the value of k is less than 1. So we'll take absolute value. So the absolute value of k is less than 1 and greater than 0. In that case, it will be horizontally stretched by a factor of 1 over k. So it will be horizontally stretched by a factor of 1 over k, right? So we are taking positive values, right? Because negative is a reflection on y-axis, so these can be combined together. That's the whole idea. Okay, so we could have combination of above also, and the last is combination of above. Okay, so let's consider another example where the k value is between 0 and 1. So let's take an example where I'll actually combine it with negative value. Okay, so let me write down a function here which is g of x equals to square root of, let us say, half x and with a negative value. Now we are doing combination. Since it is the absolute value of k is less than 1, it is horizontally compressed. So there are two things happening here. One is reflection on y-axis, and the other thing is it is horizontally stretched by factor of 1 over half means 2, right? So stretched horizontally. So let's do this transformation on the given function square root x. So the first effect is that this graph of square root of x is reflected, so we get minus square root of x on the x-axis, and the second is that it gets horizontally stretched by a factor of 2. That means all these points which we were considering, the x value gets multiplied. So this point, instead of being at minus 1, 1, it will be shown at minus 2, 1, right? And the y point will now be shown at minus 8, 2. So the figure will look like this. So what you see here is that the graph, this particular graph, which represents minus half x, where the k value is negative, means reflection on y-axis, and half means absolute value of k is between 0 and 1. It is horizontally stretched as shown here, right? So it becomes wider. Do you see that? So it becomes much wider, and the distances which we are taking are about the y-axis. So it is horizontally stretched. So I hope that gives you a fairly good idea about the functions of the type g of x equals to f of kx, where k is any real number. If k is negative, in that case the graph is reflected on the y-axis. If the absolute value of k is greater than 1, it is horizontally compressed as shown here. And if absolute value of k is less than 1, in that case it is horizontally stretched as shown in the last graph. So I hope the concept is clear. Now based on this, let us take some multiple choice questions to review. Now here are 5 multiple choice questions on transformation of functions. We are considering function g of x equals to f of kx, where k is any real number. Question number 1. If f of x is equal to minus 20001246, then f of minus half x is what? So let me rewrite this function. F of minus 0.5 is half, right? So you're looking into this function. So g of x is equal to f of minus half x. Now that will result into change of values of x coordinate, not the y, right? So based on that, you can make a selection and then look into my suggestions. Now the transformation will be that each coordinate point xy will now be transformed. The x values will become negative. Reciprocal of this is 2, so this should be multiplied by 2. So the x values get multiplied by 2, y remains the same, right? And therefore the values will be, if you multiply these x values by 2, 1 by 1, minus 2, negative will become positive, so we get 4, 0. 0, 0 will remain same, this is invariant point. 1, 2, 1 gets multiplied by minus 2, you get minus 2, y value remains same. 4 gets multiplied by minus 2 gives you minus 8, y value remains same, so that becomes our answer, which matches with option C. So I hope the concept is clear. So basically, if you have a point x, y, then it is changed to x divided by k and y remains same. So that is the transformation for a function g of x equals to f of kx, right? So use this transformation to solve such questions. The next question here is, graph of f of x is shown below. Write domain and range of f of 2x. So from the graph of f of x, we can find what domain and range is. So domain is the values along the x-axis. So domain is where x values are between 2 and 6 and both included. As far as the range is concerned, it is between 4 and 6. So that is the range, right? So it is between 4 and 6. The function we are talking about is f of 2x, right? So we are talking about g of x equals to f of 2x, right? So for f of 2x, the x values will become half, correct? So the transformation here is that if x and y are the values, then they will actually result into half of x and y, correct? So we can apply this transformation right there. Half of x will be, half of 2 is 1. So x values will now be between 1 and 3. Y values will remain same, right? Y values will remain same. So that's what we are looking into. So 1 and 3, y values remaining same between 4 and 6. Option C is the right option, right? So I hope you got the concept, correct? So let's move on and take up question number 3, which says write domain and range of f of x equals to minus 2x. So minus 2x means we are actually reflecting the graph of f of x on the y-axis. So the original graph is kind of like this, and the reflection will be here, and also, so one is the reflection, The other one is horizontally compressed, so it will become closer to y-axis, so it will kind of look like this. However, the range will not change, nor will the domain change. No, domain will change because of the reflection, right? So this is a reflection on y-axis. So you can see that the x values are now less than equal to 0. The y values are greater than equal to 0. So that is the answer. So which is matching with, so we are saying y value is greater than equal to 0 and x is less than equal to 0. So which is option C, right? So x values are less than equal to 0 and y values are greater than equal to 0. Here is question number 4, which says determine x-intercepts for the given function. Now we are given g of x as equal to f of 1/3 of x. That means the xy coordinates will be transformed and the image will be at 3xy. So let's find roots or x-intercepts of the function x squared minus 5x minus 6. X-intercepts mean y value is 0, right? So it could be factored. Minus 6 means 6 times 1, which will give us minus 5 if we have minus 6 and plus 1 as the combination, right? So that means the roots are at x equals to 6 and at x equals to minus 1. So if I do 3 times 6, so the new roots will be at 3 times 6, which is 18, right? And 3 times x value, which is minus 3. So the correct answer is 18 minus 3. So now the roots will be at 18 and minus 3. Well, unfortunately, we do not have this option here. So let me add one option E, which should have been 18 minus 3. So that becomes the x-intercepts for a function which is horizontally stretched. So they'll move away from the y-axis, right? So the answer should have been these two roots, right? So I hope that is absolutely clear. The last question here is similar to what we did while explaining. So now we have to sketch the graph of y equals to minus half x. We are given the graph for the function square root x here. So as we have learned, here we have 3 transformations, right? We have a combination. First one is reflection on y-axis, and then we have horizontal compression. Then we have horizontal stretch by a factor of 2. Do reciprocal of this. So these are the 2 combinations which takes place. Now you could actually do it in 2 steps along the graph, or you could also do transformation of points, right? So we'll do transformation of points. If I take square root x function, let's consider the points 0, 0, 1, 1, 4, 2, let's say 9, 3, right? Square root of 9. In that case, square root of minus half x will be what? 0, 0 is invariant. It won't change. Points is the xy values will get transformed to, in this case, minus twice x y. That is the image point, right? So multiply these by minus 2. So get minus 2, 1, minus 8, 2, minus 18, 3. So we can plot these points directly. So we get 1 at right there, 0. Then we get minus 2, 1, which is this point. Minus 8, 2, which is kind of here. So joining these, we get our transformed function. Correct? So that is how you could do it. You could have done it in 2 steps also, right? So 2 steps would be, first is reflection, right? And then it is horizontally stretched. So this is at 1, it comes to that point, right? Similarly, first is reflection, 4 and 2 will give you minus 4 and 2. So the first is this graph, which is the graph of square root of minus x, and after that we stretch it. So each point is stretched. That means the value which was at minus 4 will now appear at minus 8. Do you see that? The value at minus 1 will now appear at minus 2. So get horizontally stretched. So that is the combination which happens for such a graph. Correct? Now, as an exercise, I will like you to graph y equals to square root of minus 3x. Let this be the exercise for you. So I hope this video helps you to understand horizontal transformation in detail. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thanks for watching and all the best.